There are two methods that you can use in sketching, or let me better say, determining your stationary point, the coordinates that is. There are basically two ways. Three, I can say. There is one that I might also include, and that involves the calculus, but not in this problem for now. So the first method, especially if you notice that your intercepts have been given, you can use this formula, x1 plus x2 over 2. Okay? Remember, you're trying to determine the coordinates of your turning point, so a coordinate is always written in the form x comma y. So you need to know your x value, and you also need to know your y value. Okay? So when determining your x value, you can use this. X is equal to x1 plus x2 over 2. So x will be equal to, now your x1 and your x2 are just simply the roots that you had determined, your intercepts, x intercepts that you had determined. So this is just going to be 1 plus negative 2. Be mindful of the signs, very important. So 1 plus negative 2. So you're going to see that positive times negative, your answer here is going to be negative. So this is going to be 1 minus 2 over 2. And this is basically just going to be negative 1 over 2. Okay? So basically this is just going to be like negative 1 over 2. Once you find this value, your negative 1 over 2, your value of x, you can go directly and substitute this in your original equation. This was x minus 1. This is x plus 2. Y will be equal to, and then this is going to be negative 1 over 2 minus 1, negative 1 over 2 plus 2. You just get your value of x substituted. So this is now how it's going to be. And then after doing that, well, this is just simple arithmetics here. I always encourage people to be very careful with signs. This is just the same as over 1. So your common denominator here is just going to be 2. So this is going to be negative 1 minus 2, like that. Okay? Close here. You go there. This is just like over 1. So this is going to be 2 down here again. So this is going to be negative 1. But unfortunately, this is going to be plus 4. Okay, let me take this. Just wrap here. So this is now going to be y. And then negative 1 minus 2. Negative 1 minus 2. This is going to be negative 3. Right? Negative 3 over 2. And then negative 1 plus 4. This is going to be again positive 3 this time over 2. Multiplying these two directly, the negative 3, the 3, the 2, and the 2, this is going to be negative 9. Negative 9 over 4. So that's it. That's your y coordinate. Okay? That's your y coordinate. So your y value here can either be a maximum or a minimum. your y value can either be a maximum or a minimum, depending of course with the nature of the cave. But take note, the x value that you always determine is always referred to as your equation of symmetry. Your equation of symmetry. Your x value is always termed or referred to as your equation of symmetry. Your y value here can be your maximum or your minimum value. So of course, again, this is just the first way. This is just like method 1. If you want to do or use method 2 in determining your x value, well, you should basically first expand. By expansion, this is going to be y is equal to x squared plus 2x minus x minus 2, and y will be equal to x squared. 2x minus x, this is going to be plus x minus 2. Have you noticed that our y-intercept here is negative 2? Just like we had determined it here, y is equal to negative 2. So, upon doing that, if we want to, we can use this equation now. X is equal to negative b over 2a. It also works. It's also important. X is equal to negative b over 2a. Let's exercise caution. B and a are just coefficients that you obtain from your quadratic equation. Notice that the coefficient of x here is 1, so this value here, the coefficient of x squared, is a. The coefficient of x is just b, and that constant, well, it's just going to be c. So there is a 1 here, and it is positive, but it is going to be affected by that negative. So this is just going to be negative 1 over 2. The coefficient of x squared, your a, is just 1. So basically there is just like a 1 there. So this is going to be negative 1 over 2 times 1, that is just going to be 2. You see that? So your x is equal to negative 1 over 2. Alright? Just like we had determined it right here. It is also basically negative 1 over 2. So same thing, you can get that value, the negative 1 over 2, you can put it back in the original equation like we had done here, and then you can simply work out your y value in that order. But again, if you just want to handle these things simultaneously, again, provided that you have expanded it, okay, then you can just say that the coordinates of your turning point will be equated to, and then remember, it's x comma y, that's what we said. You know that your x is negative b over 2a. Your y is basically just going to be represented by this formula, however, 4ac minus b squared over 4a. So, if you wanted to go directly, just to skip the process of first finding the value of x and then you substitute it into the original equation to find your value of y. If you want to, you can just go directly by just stating that negative b over 2a comma 4ac minus b squared over 4a. You can just like basically go in this way directly. Now let's close up this matter. Let us sketch this thing. Well, it's a sketch, so it's not something that you should just do randomly. At least it needs to be represented systematically. You're just writing it anyhow. That can be a very big problem. So we have this. Let us look. Our intercepts are x is equal to 1, negative 2, so 0. We can just say 1, 2, maybe even say 3. Though I doubt if it's going to be necessary much. Negative 1. Have you seen? At least the distance from 0 to 1 and 0 to negative 1, at least they should be corresponding, you know, not whereby negative 1 is being put here. No, negative 2, right? And then we make it like this. Now listen, your y-intercept is negative 2, right? So this can be 1, this can be 2, this can be your negative 1, this can be your negative 2, like that. Now let us mark our intercepts, shall we? There is a 1 here, there is a negative 2 there, there is this y-intercept which we had also determined to be negative 2. Now of course it wouldn't make sense for someone to just come in and just do this. So never should you try to take your y-intercept as your turning point. Yeah, that's not going to be okay. In fact, it won't even be symmetrical. That's the whole reason why we are trying to determine our turning point here. And if you have followed me up, you're going to find out that your x value is negative 1 over 2, and this is negative 9 over 4. So the coordinates of your turning point is going to be negative 1 over 2, comma negative 9 over 4. Have you seen? Again, it's on the negative. And by the way this thing is going, you're going to see that indeed it's going to be a minimum like we had determined from the beginning. So your negative 1 over 2 is just like approximately 0.5. Your negative 9 over 4, if we look at it, if we approximate it, 4 into 9, that's just going to be 2 times, so negative 2, remainder 1. 4 into 1, that's going to be direct 0. It won't. So you add a decimal point, you add your 0. 4 into 10, that's just going to be 2 again, remainder 2. 4 into 2, that's going to be 0. It can't. So you add a 0 again. So 4 into 20, that's just going to be 5. So basically, negative 9 over 4 is just like negative 2.25, and your 1 over 2 is just like 0.5. So your 0.5 can be somewhere here. Your negative 2.25, okay, let me try and add the negative 3. Maybe it will make sense. So your negative 3 there. So it can be maybe somewhere here. Okay, by approximation. Now, if we try to determine the turning point, your 0.5 is here, negative, and your negative 2.25 is here, you're going to find out that the point that you're looking for is somewhere right here. So sketching will now become easier. You will know exactly where you're going to be turning. So lastly, what you're now just going to do is get your points and then you sketch them like that. Yeah, something like this. And that's it. You have made your sketch. But the final ingredient is that you shouldn't just sketch it like that. You always need to label that graph of yours. It's the one that is going to be acting as an identity for that graph that you have made. So that's it. This is how you tend to sketch quadratic equations which are in this format. Y is equal to x minus 1, x plus 2, like that. Even if you expand it, y is equal to x squared plus 2x minus 2, you play around with it, you have your y is equal to x squared plus x minus 2. You basically just do the same thing. Okay, you just basically do the same thing. So that's it for this problem.